So now it's time for online talk. So here we are having the present on of Julia Schmale from the EPF. She's the head of the String Environment Research Laboratory, and she's going to talk about the needs for robotics platform in atmosphere science in string and remote environment. Please, Julia. Thank you.
Yeah, thanks a lot for the nice introduction. Let me just share my screen. So yeah, as was just mentioned, I'm based at EPFL in Switzerland, and I'm an atmospheric scientist. So I suppose many of you don't know me because we come from different communities. And my mission for the next couple of minutes is to tell you a little bit about the needs for robotic platforms that we have in the atmospheric sciences in extreme and remote environments. Right. So, imagine the following scene. We're a bunch of happy scientists, atmospheric scientists, right? And we're full of ideas. So, somebody says, did you read about this storm? We actually really need to go inside the storm and measure there, right? Because, of course, storms are an atmospheric dynamic feature, which we'd like to understand much better. It's very important thinking of impacts to humanity. Just, think of Hurricane Ian last summer in Florida. So what about looking at bubbles in melt ponds? Think yourself in the Central Arctic. There is microorganisms that live in these melt ponds, and they emit greenhouse gases. We want to know about this to quantify climate change better than we can currently. And you know what would be really cool to learn more about the processes when the sea ice moves. So it's a really dynamic environment, but the force of the sea ice when it moves is tremendous. It can crush ships, for example. And, why not measure more vertically, go on a paraglider, take, a vehicle that has non-exhaust. So if we want to measure greenhouse gases and particles, we're not influenced by our own fossil or alternative fuel combustion, or what, actually we have a bias where we have more data in summer rather than winter, so we need to go over winter and get continuous data from the Arctic or Antarctic when it's really challenging, right? So we have all of these ideas, and this is true, so I did not just make it up, but then you run into some constraints, which is, okay, is that feasible? What about health and safety? What about insurance? What about permits? What about working hours? And so on and so forth. So what we're faced with is trying to find creative solutions where we can still put all of this into practice, because we desperately need these data if you think about climate change and sustainable development. And we're sure there is a way, and one solution to get these data is actually collaboration with your community, where we have autonomous platforms, robots that can mitigate many of the dangers and risks that we're faced with. So that's my lab. We're the Extreme Environments Research Lab. And so our mission is to measure atmospheric composition as a result of processes and interactions between the atmosphere, the cryosphere, land, ocean, and human activities to understand climate change, right? And so what we need to do is to overcome the observational and sampling biases. So essentially, no winter data, no vertical data. So these are just some of the aspects. Our background, educational background, is mostly in atmospheric sciences, physics, chemistry, meteorology. So, not so much in robotics, artificial intelligence, machine learning. And our focus is very much on the science operating the instruments, the sensors, to get the atmospheric composition data rather than the platforms themselves. So to give you a bit of an idea, I'm showing a couple of pictures, how our daily life looks like. And, at the moment, as we're speaking, we're on a mission in the Central Arctic using an icebreaker where we're trying to overcome the vertical challenge, right? So we have a tethered balloon here. This can carry 30 kilograms of sensors, and we need platforms that can carry 30 kilograms or even more, so we can actually place the current type of instrument to get that data that we want. The winter bias, right? Again, an icebreaker. This is heavy stuff to organize it. It takes you years. It's international collaborations. And, this happened before the Russian and Ukrainian war. This would not be possible at the moment to do a winter drift in the Arctic, given Russia's role there. And this is our container here that we put. So it's heavy gear, heavy logistics, long lead times, and so on and so forth. So you can't get these data more regularly or more continuously, right? So what are the needs that we have? So we want to go where and when humans shouldn't go or cannot go, right? So wintertime Arctic storms, cracking sea ice, things like that. Then there's a need to perform simple and repetitive tasks. So taking samples, essentially it's always the same. And remote control is needed. So we actually don't need to be there, but we can communicate remotely. And then I'm sure there's many other things that I haven't mentioned here that come to you naturally when you think of the challenges triggered by the images, right? So what are the challenges? Accessibility for maintenance of our instruments. It's complex instruments, actually. The environmental conditions, stormy, cold, hot, power supply, and then many other challenges, of course, as well. So I'm just going to give 3 examples to further, inspire your thoughts. So here we're measuring on a floating platform. So that's our sea ice that's cracking. You can fall in between. Getting on this platform isn't easy. And then we need to drift out further into this lead to take our measurements so we can understand emissions from the water to the atmosphere and the other way around. But then, what actually happens is there is another type of danger where humans shouldn't be around. So this is our daily life, and so caveats in this regard are we're very close to the sea ice edge. Would be better to have an autonomous platform. The persons need to go on board and launch the experiment. Would be much better, to go remotely and start and control the instruments and have live streaming of data. So we don't need to actually go and take the SD card from the instrument or connect a USB drive to the computer. That's another example. Things are simply too far away. That's the middle of Antarctica, right? We have a sampling station. Filters need to be swapped every 24 hours. And this is tedious work when it's cold, minus 30 degrees. This is something that could be performed by robots rather than humans, right? There is developments. You go from single stage to multi-stage filter samplers. So this is already happening, but wouldn't it be better or for science if we could include data or data collection for an entire year, store them and then have them transferred after a year and get much more comprehensive insights. And then, we work in the vertical quite a lot. So here's our nice payload, but it's always just under the balloon. What if we could climb up and down the tether and get, more continuous data in addition to what we have here in the balloon? So there's plenty of opportunities for where, more robotic systems could actually help us get the data we need to solve fundamental questions for climate change and sustainable development. Right? So this is just a repetition of the needs that I showed you before. And so the way forward in my vision would be, it would be fantastic to get your feedback on what I just pitched. Then we can elaborate a little bit more, identify interesting challenges for your community, the robotics community, and then have in-depth discussions, set up types of projects, try different things in these environments, in the extreme environments, to really push the boundaries of how we can obtain data and the types of insights that we would like to get. And with that, I'd like to thank you for your attention. And I'm happy to answer questions and continue discussion.
Thank you very much, Julia. Very interesting research. Is there any question in the audience?
Hi, Robert Marnie from Neurospace. Just quickly, thank you very much for your presentation. Do you have ideas of what specifically would be required, or do you just more envision that we need to apply robotics to the environmental analysis process because that's an area that can open up more avenues of research?
Yeah, so both actually. You know, what I showed here was more meant as an inspiration, so I didn't go into the details, but some of the examples would be have robotic filter samplers, right? What we try to do is capture atmospheric particles on filters, and then we bring them back to the lab and have a detailed chemical analysis, so we learn about processes. Now, this filter collection is very manual work, which doesn't have to be done by humans. I think this can be automatized quite easily. However, in extreme environments, this is not possible so far. So, you know, collecting these filters, we have a stock for, let's say, half a year, a month, or something that's feasible. There is automatic exchange, there's automatic storage, you know, and then also some data relay that we know which filter are we on, what's the temperature, and so on. This could be done. The other concrete example would be you know, a little robotic platform that can climb up and down the tether of the balloon that I showed. This, I believe, you know, that there is already some sort of implementation, but one can do much better to have, you know, very agile climbers. And then, you know, it's more about talking about specific types of measurements we do, and then there will be plenty of concrete examples of where more robotic or automatized systems could be extremely helpful and push the boundaries of what we're currently doing.
Yeah. Thank you, Mr. Schmale, for this nice presentation. And your question, I would like just to refer, I'm Armin Wähler from the German Aerospace Center. I just presented the Arches mission, which was, I see a lot of overlap what you present. So because we are working together with the Alfred Wegener Institute, with the Geoma Institute,
yes.
So they are, you know, in the research you present. And we have exactly this challenge. The project behind it was aiming for having an overlap and exchange methods between this different domains and make robotic usable for also the other approach. So I would like to short it up and would like to invite you to let's exchange contacts, because I'm currently also leading after the Arches. We have a project which is dedicated to sustainable food production. So we are much more dedicated with our space robots to the application case of predicting weather situations and this kind of stuff. So I would appreciate there's a lot of possibilities. It's a huge project, 5 years. And just start beginning of this year, maybe there's some, I will not say that I will solve any of your challenges you just said, but I can confirm that the Geoma and Alfred Wegener Institute is exactly, we have this exchange for the challenges you just mentioned. So maybe
Wonderful.
we'll exchange later.
Yes, could you restate your name?
Armin Wähler from German Aerospace Center, Robotics in Munich.
Okay, perfect. So that's DLR.
DLR, exactly.
Yes. Excellent. Thanks very much.
Welcome. And the project I'm referring to is iFoodis, and I just presented Arches, which was also
yes.
overarching deep sea or climate change research and space.
Excellent. Thank you.
Yeah, we can collect the contacts and put it online and share with in the website. So if someone is interested, can check it there. Okay, one more question.
Very good presentation. Thank you. The question I have is often, I'm very excited about the idea of automating the sensor, the replacement of the things. I do know that when people go out there on a daily basis, they tend to, oh, I need to fix this other thing. I notice this other thing is broken. I also know that those things have a power supply that might be very limited. Is there a place where we could go and learn more about not just the sample collection, but the log of what the people who do when they actually go out there would also need to be automated, and what sort of power? Like, how can those of us who are very excited about this get down into the brass tacks of thinking about your designs?
Yeah, absolutely. I mean, the best thing is, to visit our lab, and even better, to come to the field. You know, we do this with our modeling partners who will, you know, who drive the climate models or regional chemistry models. So this is, I think, the best exchange to understand what are the challenges in the field and what are actually the tasks that the experimentalists do, because it's exactly as you say, it's not one single type of instrument or platform. There's many things, and there is, you know, all this experience that the operators have to sense of, okay, so this really needs to be fixed now, or this is actually close to needing some fix. So it's, I think the best is visiting the labs, but then, you know, in Switzerland, we can go to the Jungfrau Joch, for example, which is somewhat of a remote mountain observatory, 3,500 meters high. Or, you know, in our case, we do lots of research in Greenland in relatively accessible places where, you know, a visit for 1 or 2 weeks would actually help to understand what is usually done. And then one can sit down and really design, how can we improve this?
Thank you so much for your excellent talk. I'm Lily Bay Wallace from the Southwest Research Institute, and I had a couple of, I think, more brief questions for you. The first one was, I'm currently working on a climber robot in my own lab, and I was kind of curious as to the need for transfer of physical goods between the balloon and the surface, or if there wasn't something greater that we could do to further add data connection or something like that to the tether. And then my secondary question is, I absolutely want to take the time and learn more about what the scientific community needs from this automation. And I was curious as to what your intended route was, or thoughts of enabling funding for this type of collaboration between engineering and scientific communities. Thank you.
Mm-hmm. Yeah, excellent questions. So for goods transport, absolutely. So, you know, exchanging batteries, for example, would be an interesting task. So if you have the balloon up in the air, you run out of power, but you cannot carry more batteries because it becomes too heavy. Maybe you can send up a drone and have a replacement. So I think there's many challenges along this line. Or also think of substrates that need to be transported, filter substrates, for example, or new vials or something like that. And in terms of funding, that's a really good question. I believe, you know, it depends a little bit on the system you're in which country you're based, what your national funding organizations provide. But I think also on the international level, at least in the European Union, there is the ERC synergy grants, where I think there are fantastic opportunities and good money also that could be used. And I'm sure there's other opportunities that I just don't know about at the moment.
Okay, thank you very much. Let's please thank again Julia.
Thanks very much for your attention and your great questions.
Thank you very much, Julia.